Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today, we are going to talk all about dopamine and what drives you to do the things that you do. We're going to talk about motivation and desire and craving, but also how dopamine relates to satisfaction and our feelings of well-being. And of course, any discussion about dopamine has to include a discussion about the potential for dopamine-induced addiction. Indeed, dopamine lies at the heart of addiction to all things. But today we are mainly going to focus on how what we do and how we do it and how we conceptualize those things leads to changes in this amazing molecule in our brain and bodies that we call dopamine. I'm going to teach you what dopamine is and what it is not. There are a lot of myths about the molecule dopamine. We often hear about so-called dopamine hits. Today we are going to dispel many common myths about dopamine, and we are going to talk about how dopamine actually works. We're going to discuss the biology of dopamine, the psychology. We will discuss some neural circuits, and a really exciting aspect of dopamine biology are so-called dopamine schedules. In other words, we are going to discuss how things like food, drugs, caffeine, pornography, even some plant-based compounds can change our baseline levels of dopamine, and in doing so, they change how much dopamine we are capable of experiencing from what could be very satisfying events or events that make us feel not so good because of things that we did or took prior. So I promise you it's going to be a vast discussion, but I will structure it for you, and you'll come away with a deep understanding of really what drives you. You will also come away with a lot of tools how to leverage dopamine so that you can sustain energy, drive, and motivation for the things that are important to you over long periods of time. Before we dive into the meat of today's discussion, I'd like to share with you a fascinating result that really underscores what dopamine is capable of in our brains and bodies, and underscores the fact that just through behaviors, no drugs, nothing of that sort, just through behaviors, we can achieve terrifically high increases in dopamine that are very long and sustained in ways that serve us. This is a result that was published in the European Journal of Physiology. I'll go into it in more detail later, but essentially what it involved is having human subjects get into water of different temperatures. So it was warm water, moderately cool water, and cold water. Had them stay in that water for up to an hour, and they measured, by way of blood draw, things like cortisol, norepinephrine, and dopamine. What was fascinating is that cold water exposure led to very rapid increases in norepinephrine and epinephrine, which is also just called adrenaline. It also led to increases in dopamine, and these increases in dopamine were very significant. They kicked in around 10 or 15 minutes after submersion into the cold water, and I should mention the head wasn't below water, it was just up to the neck. And the dopamine release continued to rise and eventually reach 250% above baseline. Now, what was interesting is after subjects got out of this cold water, that dopamine increase was sustained. And I know nowadays many people are interested in using cold water therapy as a way to increase metabolism and fat loss, but also to improve sense of well-being, improve cognition, improve clarity of mind. There's something really special about this very alert but calm state of mind that seems to be the one that's optimal for pretty much everything except sleep, but for all aspects of work and for social engagement and for sport, that highly alert but calm state of mind really is the sweet spot that I believe most of us would like to achieve. And this cold water exposure, done correctly, really can help people achieve that state of mind through these increases in dopamine that last a very long time. So I will later detail the specifics of that study, what it entailed in terms of how long, the variations that different subjects experienced, as well as how to limit the amount of stress hormone, cortisol, that's released as a consequence of the cold water. And we will also talk about compounds, supplements that people can take in order to increase their levels of dopamine should they choose. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. In keeping with that theme, I'd like to thank the sponsors of today's podcast. Our first sponsor is Roka. Roka makes sunglasses and eyeglasses that are of the absolute highest quality. I've spent a lifetime working on the visual system, and I can tell you that the visual system has to go through a lot of work in order to maintain clarity of what you see when there are shadows, when you go into different types of indoor lighting, and so on. And a lot of glasses don't work well because you put them on, and then you're in bright light, and you can see fine, but then you move into a shadow, and then you have to take them off, and they don't adjust, or they don't adjust quickly enough. With Roka, their eyeglasses and sunglasses are designed with the visual system biology in mind, so you always see things with perfect clarity. The glasses are also terrific because they're very lightweight, and they won't slip off your face if you're exercising, if you're running or biking. In fact, they were designed for the purpose of being able to be worn while you're engaging in those sorts of activities or simply working at your desk. I happen to wear readers at night when I drive or when I work, and I love their sunglasses because I can wear them anywhere, and also the aesthetics of their sunglasses and eyeglasses are terrific. Unlike a lot of other performance glasses that frankly make people look like cyborgs, the aesthetics on Rokas are really terrific. You could wear them anywhere you'd like to go. If you'd like to try Roka glasses, you can go to roka.com, that's ROKA.com, and enter the code Huberman to save 20% off your first order. That's Roka, ROKA.com, enter the code Huberman at checkout. Today's podcast is also brought to us by Inside Tracker. Inside Tracker is a personalized nutrition platform that analyzes data from your blood and DNA to help you better understand your body and help you reach your health goals. I'm a big believer in getting regular blood work done. And now with the advent of modern DNA tests, you can also analyze your DNA to see what you ought to be doing for your immediate and long-term health. We hear a lot these days about optimization, optimizing hormones, optimizing your metabolism, optimizing this, optimizing that. But unless you know the measurements of metabolic factors, hormones, and other things that are in your blood and DNA, you don't know what to optimize. With Inside Tracker, it makes all of that very easy. They can come to your house to take the blood and DNA test, or you can go to a nearby clinic. They send you the information, and you take those results, and unlike a lot of laboratories doing blood work out there and DNA tests, they have a simple platform, a dashboard that walks you through your results and helps you identify what sorts of nutritional or behavioral or other types of practices you might want to incorporate into your life in order to positively impact your immediate and long-term health. It's a very easy system to use, and you will gain a ton of information simply by doing that test, whether or not you end up making changes to what you're doing or not. If you'd like to try Inside Tracker, you can go to insidetracker.com/Huberman to get 25% off any of Inside Tracker's plans. Just use the code Huberman at checkout. Today's episode is also brought to us by Headspace. Headspace is a meditation app backed by 25 published studies and has over 600,000 five-star reviews. I've been meditating for a long time, but I confess sometimes I meditate and sometimes I am very inconsistent about my meditation. Ideally, I would meditate every day for 20 or 30 minutes. But what I've found over the years is that I'll start a meditation practice, and then as life gets more stressful or busier, which is exactly when I need to meditate more, I tend to meditate less often. Switching over to Headspace as a meditation app really helped me stay consistent with my meditation practice. And that's because they have a huge range of meditations to select from. Some are short, some are longer. And in general, I try and get 20 minutes of meditation in every day, but some days it's just 5 minutes, and they have some terrific just 5-minute meditations. The science says that even a 5-minute meditation can be beneficial for different aspects of our brain and body. If you want to try Headspace, you can go to headspace.com/special offer. And if you do that, you'll get 1 month as a free trial with Headspace's full library of meditations that you can use in any situation. This is the best deal offered by Headspace right now. So if you're interested, go to headspace.com/special offer to get one free 1 month trial with Headspace's full library of meditations. I'd like to announce that there's an event that some of you may find very useful. This is an event put on by Logitech that I will be speaking at. It's called Rethink Education, the Biology of Learning, Reimagining Learning Through Neuroscience. And at this event, I will be speaking. There will be other speakers as well. And I will be talking about neuroplasticity and its applications for teaching and for learning. I will describe what I call the plasticity super protocol that incorporates all of what we know about rapid learning, efficient learning, and the best ways to teach and learn. It's geared towards educators of all kinds. It is zero cost. So please feel free to sign up. The event is September 30th, 2021 at 3 p.m. Eastern. You can find the registration link in the caption for this episode. So let's talk about dopamine. Most people have heard of dopamine, and we hear all the time now about dopamine hits. But actually, there's no such thing as a dopamine hit. And actually, the way that your body uses dopamine is to have a baseline level of dopamine, meaning an amount of dopamine that's circulating in your brain and body all the time. And that turns out to be important for how you feel generally, whether or not you're in a good mood, motivated, etc. And you also can experience peaks in dopamine above baseline. Now, this has a very specific name in the neurobiology literature, so-called tonic and phasic release of dopamine. And I'll explain what that means in a couple of minutes. But if you remember nothing else from this episode, please remember this, that when you experience something or you crave something really desirable, really exciting to you, very pleasurable, what happens afterwards is your baseline level of dopamine drops. Okay, so these peaks in dopamine, they influence how much dopamine will generally be circulating afterward. And you might think, oh, a big peak in dopamine. After that, I'm going to feel even better because I just had this great event. Not the case. What actually happens is that your baseline level of dopamine drops. And I will explain the precise mechanism for that. Okay, in the neuroscience literature, we refer to this as tonic and phasic release of dopamine. Tonic being the low level baseline that's always there circulating, released into your brain all the time. And then phasic, these peaks that ride above that baseline. And those two things interact. And this is really important. I'm going to teach you the underlying neurobiology, but even if you have no background in biology, I promise to make it all clear. I'll explain the terms and what they mean. And I'm excited to teach you about dopamine because dopamine has everything to do with how you feel right now as you're listening to this. It has everything to do with how you will feel an hour from now. It has everything to do with your level of motivation and your level of desire and your willingness to push through effort. If ever you've interacted with somebody who just doesn't seem to have any drive, they've given up, or if you've interacted with somebody who seems to have endless drive and energy, what you are looking at there in those two circumstances is without question a difference in the level of dopamine circulating in their system. There will be other factors too, but the level of dopamine is the primary determinant of how motivated we are, how excited we are, how outward facing we are, and how willing we are to lean into life and pursue things. Dopamine is what we call a neuromodulator. Neuromodulators are different than neurotransmitters. Neurotransmitters are involved in the dialogue between neurons, nerve cells, and neurotransmitters tend to mediate local communication. Just imagine two people talking to one another at a concert. That communication between them is analogous to the communication carried out by neurotransmitters, whereas neuromodulators influence the communication of many neurons. Imagine a bunch of people dancing where it's a coordinated dance involving 10 or 20 or hundreds of people. Neuromodulators are coordinating that dance. In the nervous system, what this means is that dopamine release changes the probability that certain neural circuits will be active and that other neural circuits will be inactive. Okay, so it modulates a bunch of things all at once. And that's why it's so powerful at shifting not just our levels of energy, but also our mindset, also our feelings of whether or not we can or cannot accomplish something. So how does dopamine work and what does it do? Well, first of all, it is not just responsible for pleasure. It is responsible for motivation and drive, primarily at the psychological level. Also for craving. Those three things are sort of the same, motivation, drive, and craving. It also controls time perception. And we will get deep into how dopamine can modulate time perception and how important it is that everybody be able to access increases in dopamine at different time scales. This turns out to be important to not end up addicted to substances, but it also turns out to be very important to sustain effort and be a happy person over long periods of time, which I think most everybody wants. It certainly is adaptive in life to be able to do that. Dopamine is also vitally important for movement. I'll explain the neural circuits for dopamine and mindset and dopamine in movement in a moment, but in diseases like Parkinson's, or Lewy body's dementia, which is similar to Parkinson's in many ways. There's a depletion or death of dopamine neurons at a particular location in the brain, which leads to shaky movements, challenges in speaking, challenges in particular in initiating movement. And because dopamine is depleted elsewhere too, people with Parkinson's and Lewy body dementia also experience drops in motivation and affect, meaning mood. They tend to get depressed and so on. When those people are properly treated, they can, not always, but they can recover some fluidity of movement, some ability to initiate movement, and almost without question, those people feel better psychologically, not just because they can move, but also because dopamine impacts mood and motivation. So what are the underlying neural circuits? For those of you that are not interested in biology and specific nomenclature, you can tune out now if you want, but it's actually pretty straightforward. You have two main neural circuits in the brain that dopamine uses in order to exert all its effects. The first one is a pathway that goes from this area in the what's called the ventral tegmentum. That's a fancy, but ventral just means bottom, and tegmentum actually means floor. So it's at the bottom of the brain, and it's the ventral part of the floor, so it's really low in the back of the brain, the ventral tegmentum, and it goes from the ventral tegmentum to what's called the ventral striatum and the prefrontal cortex. Now, that's a lot of language, but basically what we call this is the mesocorticolimbic pathway. This is the pathway by which dopamine influences motivation, drive, and craving. It involves structures that some of you may have heard of before, things like nucleus accumbens and the prefrontal cortex. This is the pathway that really gets disrupted in addictions, where in particular, drugs that influence the release of dopamine, like cocaine and methamphetamine, we'll talk about those drugs today, they tap into this pathway. But if you are pursuing a partner, a boyfriend or girlfriend, if you're pursuing a degree in school, if you're pursuing a finish line in a race, you are tapping into this so-called mesocorticolimbic pathway. This is the classic reward pathway in all mammals. The other pathway emerges from an area in the brain called the substantia nigra, so called because the cells in that area are dark, and the substantia nigra connects to an area of the brain called the dorsal striatum. This is, not surprisingly, called the nigrostriatal pathway. For those of you who have never done any neuroanatomy, I'm going to teach you a little trick right now. Everything in neuroanatomy, the first part of a word tells you where the neurons are. And then the second part tells you where they are connecting to. So when I say nigrostriatal pathway, it means that the neurons are in substantia nigra and they connect to the striatum, nigrostriatal pathway. So while it's a lot of language, there is some logic there. Okay, so we've got these two pathways, one mainly for movement, right? This is the substantia nigra to dorsal striatum. And we've got this other pathway, the so-called mesocorticolimbic pathway, that's for reward, reinforcement, and motivation. I want you to remember that there are two pathways. If you don't remember the two pathways in detail, that's fine. But please remember that there are two pathways, because that turns out to be important later. Now, the other thing to understand about dopamine is that the way that dopamine is released in the brain and body can differ, meaning it can be very local or it can be more broad. Now, most of you have probably heard of synapses. Synapses are the little spaces between neurons. And basically neurons, nerve cells, communicate with one another by making each other electrically active or by making each other less electrically active. So here's how this works. You can imagine one nerve cell and another nerve cell with a little gap between them, a little synapse. And the way that one nerve cell causes the next nerve cell to fire, what we call fire really means to become electrically active, is that it vomits out these little packets, what we call vesicles. They're little bubbles filled with a chemical. When that chemical enters the synapse, some of it docks or parks on the other side in the other neuron. And by virtue of electrical changes in what we call the postsynaptic neuron, that chemical will make that neuron more electrically active or less electrically active. Dopamine can do that like any other neurotransmitter or neuromodulator. So it can have one neuron influence another neuron, but dopamine can also engage in what's called a volumetric release. Volumetric release is like a giant vomit that gets out to 50 or 100 or even thousands of cells. So there's local release, what we call synaptic release, and then there's volumetric release. So volumetric release is like dumping all this dopamine out into the system. So dopamine is incredible because it can change the way that our neural circuits work at a local scale and at a very broad scale. And for those of you that are only interested in tools, like how do I get more dopamine? Let me tell you, this part is really important because if you were to take a drug or supplement that increases your level of dopamine, you are influencing both the local release of dopamine and volumetric release. This relates back to the baseline of dopamine and the big peak above baseline. And that turns out to be important. And I'll just allude to why it's important. Many drugs, and indeed many supplements that increase dopamine, will actually make it harder for you to sustain dopamine release over long periods of time and to achieve those peaks that most of us are craving when we are in pursuit of things. Why? Because if you get both volumetric release, the dumping out of dopamine everywhere, and you're getting local release, what it means is that the difference between the peak and baseline is likely to be smaller. And this is very important, how satisfying or exciting or pleasureful a given experience is doesn't just depend on the height of that peak. It depends on the height of that peak relative to the baseline. So if you increase the baseline and you increase the peak, you're not going to achieve more and more pleasure from things. I'll talk about how to leverage this information in a little bit, but just increasing your dopamine, yes, it will make you excited for all things. It will make you feel very motivated, but it will also make that motivation very short-lived. So there's a better way to increase your dopamine. There's a better way to optimize this peak to baseline ratio. For now, what we've talked about is two main neural circuits, one for movement and one for motivation and craving with dopamine. And we've talked about two main modes of communication between neurons with dopamine. One is this local synaptic release. One is more volumetric release. And in the back of your mind, you can relate this back to, again, this baseline versus peaks above baseline. So that's a description of what we would call the spatial effects or the spatial aspects of dopamine. I said this connects to that connects to this. You can get local or more broad volumetric release. What about the duration of release or the duration of action for dopamine? Well, dopamine is unique among chemicals in the brain because dopamine, unlike a lot of chemicals in the brain, works through what are called G-protein coupled receptors. And for those of you that are about to pass out from the amount of detail, just hang in there with me. It's really not complicated. There are two ways that neurons can communicate, or mainly two ways. There are a third and a fourth, but mostly neurons communicate by two modes. One are what we call fast electrical synapses, ionotropic conduction. All right. You don't need to know what that means, but basically one neuron activates another neuron and little holes open up in that neuron and ions rush in. Sodium is the main ion, salt, by which one neuron influences the electrical activity of another neuron because sodium ions contain a charge. Okay. There are other things like chloride and potassium. If you're interested in looking this up, just look up ionic conductances in the action potential, or I could do a post on it sometime and we could go into detail, but just understand that when neurons want to influence each other, they can do it by way of this fast ionotropic conduction. This is a really quick way for one neuron to influence the next. Dopamine doesn't communicate that way. Dopamine is slower. It works through what are called G-protein coupled receptors. So what happens is dopamine is released in these little vesicles that I mentioned before, get vomited out into the synapse. Some of that dopamine will bind to the so-called postsynaptic neuron. It'll bind to the next neuron, and then it sets off a cascade. It's kind of like a bucket brigade of one thing getting handed off to the next, to the next, to the next. It's G-protein coupled receptors. And anytime you hear about these GPCRs or G-protein coupled receptors, pay attention because they're really interesting. They're slow, but they also can have multiple cascades of effects. They can impact even gene expression at some level. They can change what a cell actually becomes. They can change how well or how poorly that cell will respond to the same signal in the future. So dopamine works through this slower process, these G-protein coupled receptors. And so its effects tend to take a while in order to occur. This aspect of dopamine transmission is important because it now underscores two things. One, there's two pathways for dopamine to communicate, one for movement, one for motivation and craving. There's two spatial scales at which dopamine can operate, synaptically or volumetrically, and dopamine can have slow effects, really slow effects, or even very long-lasting effects. And it even can control gene expression. It can actually change the way that cells behave. One thing that's not often discussed about dopamine, but is extremely important to know, is that dopamine doesn't work on its own. Neurons that release dopamine co-release glutamate. Glutamate is a neurotransmitter, and it's a neurotransmitter that is excitatory, meaning it stimulates neurons to be electrically active. So now, even if you don't know any cell biology, you should start to gain a picture that dopamine is responsible for movement, motivation, and drive. It does that through two pathways, but also that dopamine stimulates action in general because it releases this excitatory neurotransmitter. It tends to make certain neurons that are nearby or even that are far away because of volumetric release, it tends to make those more active. So dopamine is really stimulating. And indeed, we say that dopaminergic transmission, or dopamine, tends to stimulate sympathetic arousal. Sympathetic doesn't have anything to do with sympathy. It just simply means that it tends to increase our levels of alertness. It tends to bring an animal or a human into a state of more alertness, readiness, and desire to pursue things outside the confines of its skin. So if I were to just put a really simple message around dopamine, it would be there's a molecule in your brain and body that when released tends to make you look outside yourself, pursue things outside yourself, and to crave things outside yourself. The pleasure that arrives from achieving things also involves dopamine, but is mainly the consequence of other molecules. But if ever you felt lethargic and just lazy and you had no motivation or drive, that's a low dopamine state. If ever you felt really excited, motivated, even if you were a little scared to do something, maybe you did your first skydive, or you're about to do your first skydive, or you're about to do some public speaking and you really don't want to screw it up, you are in a high dopamine state. Dopamine is a universal currency in all mammals, but especially in humans, for moving us toward goals, and how much dopamine is in our system at any one time compared to how much dopamine was in our system a few minutes ago, and how much we remember enjoying a particular experience of the past. That dictates your so-called quality of life and your desire to pursue things. This is really important. Dopamine is a currency, and it's the way that you track pleasure. It's the way that you track success. It's the way that you track whether or not you are doing well or doing poorly. And that is subjective. But if your dopamine is too low, you will not feel motivated. If your dopamine is really high, you will feel motivated. And if your dopamine is somewhere in the middle, how you feel depends on whether or not you had higher dopamine a few minutes ago or lower dopamine. This is important. Your experience of life and your level of motivation and drive depends on how much dopamine you have relative to your recent experience. This is, again, something that's just not accounted for in the simple language of dopamine hits. Okay? A simple way to envision dopamine hits is every time you do something you like, you eat a piece of chocolate, dopamine hit. You look at your Instagram, dopamine hit. You see someone you like, dopamine hit. You know, all these things described as dopamine hits neglect the fact that if you scroll social media and you see something you really like, dopamine hit. Sure, there's an increase in dopamine. But then you get to something else and you go, not that interesting. However, had you arrived at that second thing first, you might think that it was really interesting. If you had arrived to that second Instagram post 3 days later or 4 days later, you might find it extremely interesting. Again, how much dopamine you experience from something depends on your baseline level of dopamine when you arrive there and your previous dopamine peaks. Okay? That's super important to understand, and it's completely neglected by the general language of dopamine hits. This is why when you repeatedly engage in something that you enjoy, your threshold for enjoyment goes up and up and up. So I want to talk about that process, and I want to explain how that process works, because if you understand that process and you understand some of these schedules and kinetics, as we call them, around dopamine, you will be in a terrific position to use any dopamine-enhancing tools that you decide to use. You'll be in an excellent position to modulate and control your own dopamine release for optimal motivation and drive. I realized that was a lot of information about the biology of dopamine, sort of like trying to make you drink from the fire hose of dopamine biology. However, I realize that some people probably want even more information about the biology of dopamine transmission. If you're interested in that, I'll post a link to an absolutely stellar review that was published in Nature Reviews Neuroscience called Spatial and Temporal Scales of Dopamine Transmission. It is quite detailed, but they have beautiful diagrams and can walk you through all the things that I just described and get into even more detail. We'll put a link to that in the caption on YouTube. Right now, I want to share with you two anecdotes, one from my own life and one from some fairly recent history, that illustrate some of the core biology of dopamine and how profoundly it can shape our experience. The first one is a really tragic situation that occurred. This was in the 80s. There was a outbreak of what looked like Parkinsonian symptoms in a young population. So many of you have heard of Parkinson's disease. Parkinson's disease is a disease in which people initially start to quake, can't generate smooth movements. They'll have issues with speech, sometimes cognition as well. There are examples like Michael J. Fox, which are kind of early onset Parkinson's. Typically, it hits people a little bit later in life. There's a genetic component, but there is this question, and there's always been this question, whether or not certain lifestyle factors can also create Parkinson's. And some years ago, there was a situation where street laboratories, illicit laboratories, were trying to make a drug called MPPP, which is an opioid-like compound. It's a bit like heroin. And heroin addicts seeking heroin went out and bought what they thought was MPPP. Unfortunately, it was not MPPP. I mean, it would have been tragic if it was anyway, because they were drug addicts. But what they ended up taking turned out to be a lot worse. What they ended up taking was MPTP. And MPTP can arise in the synthesis of MPPP. So someone in a lab someplace, this was mainly in the Central Valley in California, but elsewhere as well, somebody created MPTP. And what ended up happening was a large number of young people who were opioid addicts became completely boxed in, paralyzed. Couldn't speak, couldn't blink, couldn't do anything, couldn't function, couldn't move. So both aspects of dopamine transmission were disrupted. They had no motivation and drive. They couldn't generate any movement of any kind. They were literally locked in, frozen. And sadly, this is irreversible. It's irreversible because what MPTP does is it kills the dopaminergic neurons of the substantia nigra, that nigrostriatal pathway that's involved in generating movement, and it kills the dopaminergic neurons of the so-called mesocortical limbic pathway. I was in college when this whole MPTP thing happened, and I remember hearing this story. At the time, I had no understanding of what it is to have very high levels of dopamine or extremely depleted levels of dopamine. There was no reason why I should have that understanding. I mean, of course, I had experienced different pleasures of different kinds, and I've had lows in my life, but nothing to the extreme that I'm about to discuss. I got Giardia, and Giardia is a stomach bug that, if any of you have ever had it, it is terrible. It's terrible diarrhea. You end up very dehydrated very quickly. You drop a ton of weight, and it is extremely unpleasant. I ended up going to the emergency room, and in the emergency room, I begged them for something to stop up my guts, and they gave it to me. They put a saline line in to rehydrate me, and they injected something into the saline bag, and within minutes, I felt more sadness, more overwhelming sense of depression, basically lower than I'd ever felt in my entire life. It was absolutely profound. I was crying endlessly without knowing why I was crying. I was miserable. And I asked them, what did you inject? And they said, we injected Thorazine. Thorazine is an antipsychotic drug. It's actually used to block dopamine receptors. It's what's given to people who have schizophrenia, often is given to people who have schizophrenia, because schizophrenia involves, among other things, elevated levels of dopamine. It was horrible. The experience of it was miserable, unlike anything I'd ever experienced. And so I actually said to them, what did you give me? They said Thorazine. And I said, you have to give me L-Dopa. You have to give me something to get my dopamine levels back up again. And they did. They gave me an injection of L-Dopa into the bag, went straight into my bloodstream, and within minutes, I felt fine again. It was incredible, and it really opened up my mind and my experience to what it is to have absolutely plummeted levels of dopamine. There's nothing more miserable than that, I'll tell you. And these poor souls who had this MPTP experience, unfortunately, they couldn't recover those cells. People who have severe Parkinson's are struggling with this as well, because in Parkinson's and in Lewy body dementia, the dopaminergic neurons often die. It's not just a problem with those neurons releasing enough dopamine. Later, we're going to talk about some approaches to maintaining dopaminergic neuron health and things that we can all do for that. But I will tell you, these dopamine neurons that we all have are very precious for movement and mood and motivation. Having experienced what it is to have very, very low levels of dopamine, or to, in this case, to have my dopamine receptors blocked from Thorazine, was eye-opening, to say the least, and has given me tremendous sensitivity to the fact that dopamine is perhaps one of the most powerful molecules that any of us has inside of us, and the one that we ought to all think very carefully about how we leverage. Because while most experiences and most things that we do and take and eat and et cetera won't create enormous highs and enormous lows in dopamine, even subtle fluctuations in dopamine really shape our perception of life and what we're capable of and how we feel. And so we want to guard those and we want to understand them. So let's lean into that understanding about dopamine, and then let's talk about some tools that we can all use to leverage dopamine in order to keep that baseline in the appropriate healthy place and still be able to access those peaks in dopamine, because those, after all, are some of what makes life rich and worth living. So let's talk about the baseline of dopamine that we all have and the peaks in dopamine that we all can achieve through different activities and things that we ingest. All of us have different baseline levels of dopamine. Some of this is sure to be genetic. Some people just simply ride at a level a little bit higher. They're a little bit more excited. They're a little bit more motivated. Or maybe they're a lot more excited or a lot more motivated. Some people are a little mellower. Some people are a little less excitable. And some of that has to do with the fact that dopamine doesn't act alone. Dopamine has close cousins or friends in the nervous system, and I'll just name off a few of those close cousins and friends. Epinephrine, also called adrenaline, is the main chemical driver of energy. We can't do anything at all, unless we have some level of epinephrine in our brain and body. It's released from the adrenal glands, which ride atop our kidneys. It's released from an area of the brainstem called locus ceruleus. And its release tends to wake up neural circuits in the brain and wake up various aspects of our body's physiology and give us a readiness. So it should come as no surprise that dopamine and epinephrine, aka adrenaline, hang out together. In fact, epinephrine and adrenaline are actually manufactured from dopamine. There's a biochemical pathway involving dopamine, which is a beautiful pathway. If ever you want to look it up, you could just look up biochemistry of dopamine. But what you'll find is that L-Dopa is converted into dopamine. Dopamine is converted into noradrenaline, norepinephrine, it's also called. And norepinephrine is converted into adrenaline. So not only are dopamine and epinephrine, aka adrenaline, close cousins, they are actually family members. Okay, they're closely related. I'm not going to get too deep into epinephrine today. I'm not going to talk too much about those pathways. But anytime I'm talking about dopaminergic transmission, or that you have a peak in dopamine, inevitably that means that you have a peak in release of epinephrine as well. What dopamine does is dopamine really colors the subjective experience of an activity to make it more pleasurable, to make it something that you want more of. Epinephrine is more about energy. Epinephrine alone can be fear, paralysis, trauma, not physical paralysis, but mental paralysis, frozen in fear.